Take a moment and observe the objects that quietly exist around you every single day. A pencil resting on your desk, sneakers placed near the door, a box of crayons in a drawer, or a few Lego bricks stored from childhood memories. These items feel ordinary because they are deeply integrated into our daily routines, yet their creation is far more complex than most people ever imagine. Behind every simple object lies a sophisticated journey involving advanced machinery, precision engineering, carefully selected raw materials, and the coordinated effort of skilled professionals. In a world where people often admire futuristic technology and large-scale innovations, the true brilliance of modern manufacturing frequently hides within the smallest and most familiar products. Before these everyday items reach your hands, they pass through high-temperature processing, automated production lines, rigorous quality inspections, and carefully monitored manufacturing environments. What appears simple on the surface is actually the result of decades of research, refinement, and technological evolution. Today, we are stepping inside the hidden world of production to uncover how some of the most common everyday things are made. And once you understand their journey, you will begin to see ordinary objects with a completely new level of respect and fascination. 1. Lego. Precision in every brick. A Lego brick may seem like a basic toy, but in reality, it is one of the most precisely engineered consumer products ever manufactured. The process begins with tiny plastic pellets made from high-grade ABS plastic, a material specifically chosen for its durability, strength, and consistent finish. These pellets are transported into highly advanced injection molding machines, where they are heated to extremely high temperatures until they transform into molten liquid plastic. This molten plastic is then injected into hardened steel molds under intense pressure. These molds are designed with microscopic accuracy because even the smallest variation in size can prevent bricks from fitting together perfectly. Once the plastic fills the mold, it cools rapidly and solidifies into the iconic Lego shape within seconds. However, the production process does not stop at shaping. Each brick moves through automated inspection systems equipped with high-resolution cameras and precision sensors that scan for even the tiniest defects or imperfections. Any flawed piece is instantly removed and recycled to maintain strict quality standards. This extraordinary level of precision is the reason Lego bricks manufactured decades ago still connect flawlessly with newly produced ones. That satisfying clicking sound when two bricks snap together is not just a design feature, it is the result of world-class engineering, technological consistency, and meticulous quality control. 2. Pencils. From natural resource to refined instrument, the pencil is one of the most essential tools in human history, yet its manufacturing process is a remarkable combination of natural sourcing, chemical processing, and mechanical craftsmanship. The journey begins in sustainably managed forests, where carefully selected trees are harvested and transported for processing. These logs are cut into thin wooden slats and dried under controlled environmental conditions to ensure stability, durability, and resistance to warping over time. While the wood is being prepared, the internal core of the pencil is produced separately. Commonly referred to as lead, it is actually made from a precise mixture of graphite and clay. The ratio between these materials determines the hardness, smoothness, and darkness of the pencil's writing performance. And this mixture is blended with water, shaped into thin rods, and baked in high-temperature kilns until it becomes solid, durable, and perfectly structured. Precision grooves are then carved into the wooden slats, and the graphite rods are carefully placed inside with exact alignment. Another slat is glued on top to form a layered block structure, which is compressed firmly to create a strong bond. Once dried, shaping machines cut the blocks into the familiar hexagonal or round pencil form. The pencils are then sanded for smoothness, coated with multiple layers of paint, polished for a refined finish, and finally fitted with a metal ferrule and eraser. What begins as a natural raw material ultimately transforms into a precise writing instrument, used in education, design, engineering, and creative expression worldwide. 3. Sneakers. Engineering for comfort, support, and performance. Sneakers are far more than simple footwear. They are carefully engineered products designed to support human movement, absorb impact, and provide long-term comfort. The production process begins with advanced digital design, where engineers study foot anatomy, walking patterns, flexibility, and pressure distribution to create highly accurate prototypes. Every curve, layer, and material selection is strategically planned before manufacturing even begins. Large rolls of fabric, mesh, leather, or synthetic materials are fed into computer-controlled cutting machines that ensure precise dimensions and minimal material waste. These components are then stitched together to form the upper structure of the shoe, combining automated sewing technology with skilled human craftsmanship for maximum consistency and durability. Simultaneously, the sole is manufactured using specialized rubber compounds and performance foam materials. These materials are heated and molded under controlled pressure to create cushioning midsoles and durable outsoles that provide grip and shock absorption. Once both sections are prepared, they are carefully aligned and bonded together using industrial adhesives and heat pressing systems that ensure structural strength and comfort. After assembly, sneakers undergo rigorous quality testing, including flexibility simulations, impact resistance analysis, and long-term durability checks. Machines repeatedly bend, compress, and stress the shoes to replicate real-world usage conditions. Only products that meet strict performance and safety standards proceed to packaging. The sneakers we wear daily are the result of biomechanics, engineering innovation, and precision manufacturing working together to enhance movement and comfort. 4. Crayons, the chemistry of color and creativity. Crayons may appear simple, yet their production is a carefully controlled industrial process rooted in chemistry, temperature regulation, and color science. The process begins with paraffin wax, which is melted in large temperature-controlled tanks to achieve a smooth and consistent liquid base. Maintaining precise heat levels is essential to ensure the correct texture and structural stability of the final product. Once the wax reaches the required consistency, high-quality pigments are added to create vibrant and uniform colors. These pigments are measured with extreme accuracy because even minor variations can affect shade consistency and performance. The mixture is continuously stirred to ensure even distribution of color before being poured into precision-designed crayon molds. These molds allow the wax to cool gradually and solidify evenly, preventing cracks, air bubbles, or structural weaknesses. After hardening, the crayons are carefully removed and inspected for surface quality, smoothness, and durability. Automated wrapping machines then apply perfectly aligned labels at high speed, ensuring uniform presentation. Before final packaging, samples from each batch are tested for coloring smoothness, break resistance, and color consistency to guarantee a reliable and enjoyable user experience. Redefining the meaning of ordinary, everyday objects may appear simple, but their creation represents a powerful fusion of science, engineering, innovation, and human dedication. A Lego brick reflects microscopic precision. A pencil represents the transformation of nature into functionality. Sneakers embody biomechanical engineering, and crayons demonstrate the balance of chemistry and creativity. Behind these familiar items are advanced factories, skilled technicians, quality control specialists, and engineers who continuously refine production processes to achieve perfection and consistency. These objects silently support our daily lives, while carrying within them layers of technological advancement and thoughtful design. The next time you pick up a pencil, lace your sneakers, connect Lego bricks, or use a crayon to bring color to a blank page, pause for a moment and reflect on the hidden journey behind that object. What seems ordinary is, in reality, the outcome of precision manufacturing, intelligent design, and coordinated human effort. Understanding how everyday things are made does not just inform us, it deepens our appreciation for the invisible systems of innovation that shape our modern world.